Hello everybody and welcome to the afternoon session of Virtual Cell Webinars. My name is Bob Cosmano. I'm project manager here at WoWiWe Instruction Company, and we're going to show off our new educational video game, the Virtual Cell. As you see on the screen here, if you want to shoot us a question, we'll have a short Q&A at the end of probably a half-hour session. You can either chat directly here on Twitch TV if you have an account, or email us at support@wowiwe.net, and I'll look for your emails at the end of the program. Besides that, I believe we'll just jump right into the game. We're all here to see Virtual Cell. So the Virtual Cell is a product of WoWiWe Instruction Company. We've been working on this for a couple years here. We have taken an old idea of modeling out a 3D plant cell. We did a few animations in this style and put them up on the web, and now we've taken this idea and folded it into a video game. We've modeled out in 3 dimensions a full plant cell with organelles and the biological processes that you teach in class. We've tried to hit all the high notes of every biology class out there. Things like the electron transport chain, we'll see a little bit of photosynthesis, osmosis, cell structure, just the major highlights from any textbook, any high school curriculum out there. I've logged in. This character, you can see, is in our plant cell. We've skipped a little bit of the tutorial. We're here in what we call our identification module. It's where we're getting the player used to navigating in the game, teaching them what all of these colorful shapes are in the interior, and we have goals like identify a Golgi apparatus. And this is where we're trying to introduce them into a scientific way of thinking. In a real-world lab, you identify cell organelles by centrifuging things and staining them in acids and such. But here in this 3D virtual space, we can do whatever a video game can do. So we can see things like the mitochondrion pumping out little particles of ATP, these energy molecules coming off of it, just like it would in a real cell. We can see the nucleus here, and see through its thin little membrane and notice DNA coiled up inside, endoplasmic reticulum folded all around the nucleus, just like you would find it in a 3D cell. In a textbook, all of these would be two-dimensional diagrams and microscopic thin sections and cutaway illustrations. Here we have modeled everything out as it would appear in a real cell, as you can't see in the real world. We have found that students can grasp the concepts much more quickly by having this 3D virtual space to explore, rather than separating, your cell structure and your photosynthesis chapters might be hundreds of pages apart in a textbook, weeks apart in the classroom. By situating them in a 3D space, students can make the connections between them much more easily. So let's go ahead and finish off the identification module. I've left this character one goal to go. This identified fellow is our Golgi apparatus we're looking for. And it's not enough to merely say it's a Golgi apparatus. You'll see by interacting with this, we scan it with a little submarine scanner beam. We have everything we're carrying in our inventory right here. We have all of the assays and reports, a torpedo we're carrying around. So it is not enough to merely report this as a Golgi apparatus. This will send a message to our server saying, hey, we found a Golgi, but we haven't performed any tests yet. So the server sees that message and says, it's not enough to merely guess. This is not what a scientist would do. This is not the scientific method. We haven't proved that with an assay yet. So it encourages us to go back and actually perform the test. As much as possible, we have tried to circumvent brute force and guessing from the student's perspective. We want them to think like a scientist and perform experiments like these assays here. We've chosen these identifying molecules like chlorophyll, protein biosynthesis. These will uniquely identify the organelles in the cell. So we have to choose the one that uniquely identifies a Golgi apparatus and fire it, which I happen to know is glycosyl transferase. So if we shoot out that little ring of light, we get to see through the outside of the structure and see the little curlicues of glycosyl transferase in there. We have detected glycosyl transferase. So you might notice our goal at the top is still Golgi Apparatus, but our task has changed from perform assay to report that we found it. That fades back in, and now we can go back and report this. So because these messages are sent to the server responds with our little robot partner coming down and telling us good job, correct. We're also able to detect on our server patterns of people trying to brute force. The more we do random guesses, the more this robot will come down with hints and guidance to try to get us back on task, try to keep us performing experiments before making reports. If we notice that a student is struggling with the concept, but not necessarily randomly guessing, these robot tutors, we call them, are able to detect that and come down with a different kind of encouragement and access, guiding them towards our in-game encyclopedia, towards some mini games that help illustrate the subject, whatever it thinks is necessary to get the student up to speed. And now that we have identified our last organelle, our goal has changed. Our goal is now to go check out the Electron transport chain module. And as much as possible, we try to use real-world biology in our gameplay as invisibly as possible. That's why chloroplasts, like up here, and mitochondria are throwing out the ATP particles. That's the energy currency of the cell, is how it's always described. Well, that's what also powers our submarine. You see here, our submarine runs on adenosine triphosphate, ATP as well. You receive this as a reward for doing goals and tasks, and if you run out, your submarine slows way down. So it's in your best interest to keep moving through the goals in the game. So the Golgi Apparatus, its task is to absorb little vesicles, route proteins and molecules inside the cell or to other cells by butting off little pieces of it. So when we want to travel between cells, well, we built that into the Golgi Apparatus. We're going to go see the electron transport chain. We have a little loading screen between rooms, again reinforcing the fact that we're butting off of one cell going to another. And that, it's important to note, is not a part of any of the goals and tasks we have set up. It's not a major module, it's just one of those pieces of learning trying to fold actual biology concepts into the game. So when they're done playing the game, they realize that the Golgi Apparatus is in charge of routing things. Oh, a robot has been sent by the server again. Hello, we are entering the Electron transport chain module. And here is where he could give you some tutorial, set you up for the module. I happen to know what I'm doing, so I'll talk to him later. Good hunting, robot. So now we are in a different cell. This is about cell respiration, the electron transport chain. So this room has many, many more mitochondria. You can see them all over the place now. We try to build each room to emphasize the organelle that is being focused on that module. And so the student has many opportunities to go in and repair things. Our first task here, at the top of the screen, is to enter a healthy mitochondrion. This one looks healthy. It's pumping out ATP all over the place. So let's go in here. So we scan it. And at this level, now that we're getting into the more complicated learning, we start going inside the organelles. Enter the mitochondrion. So the first level is just identifying them, knowing where you are in the cell. Now we start adding on the interiors of the organelles, what they look like inside, what the process is. For the electron transport chain, it is, of course, the robot says, great, we're keeping up with our goals and tasks. We are now in a mitochondrion, and here's the electron transport chain. See, all the major proteins here are represented, shuttling electrons from one side to the other. Long names like cytochrome C reductase doing its business. And eventually protons get pumped out through here onto the top side and come back through ATP synthase to make ATP. And this is the basis for really the rest of our game, is this structure of we guide the student to view the healthy process. You see right there, protons being pumped. So they are able to look at what it should be doing. And then we send them out into the rest of the cell where the process is broken. So it is their job to perform experiments on the electron transport chains or the photosynthesis, determine what has been broken, and then fix it. And this is a scaffolding technique. This is authentic instruction, role-based learning, whatever educational buzzwords you like to put to it. But this is what we've been doing for 10 years now. And it has been proven that this helps students learn at least as well as a textbook, and they enjoy it about 10 times more. We've seen the process. The robot says, okay, we've done that. And now it introduces us to the concept of the experimentation. This is where, molecules impact against the electron transport chain, and we see whether it works or not. Sounds easy enough. It's given us an oxygen, but in this case, we're joined in the mitochondria by a fellow developer, Otto Borkert. I believe he is ready to fire an oxygen as well. And this is the multiplayer aspect. Because this game talks to our server all the time, we're able to send those software tutors down to give feedback, and we're also able to play in multiplayer. In a classroom setting, you would see dozens of yellow submarines like Otto. He's giving me a look. Dozens of these submarines running around performing their own assays, their experiments. Oh, there goes oxygen. Yes, and so when oxygen impacts cytochrome C oxidase, if the protein is working, we see the electron transport chain reset, and we get sparkles and a fun sound, and that is how they perform experiments against these proteins, much like that. So we viewed the healthy ETC. Our task is now to exit. The problem is, the poor robot doesn't have any more oxygen to give us. I'm ready to go. So in order to get those molecules, we send the player to where a cell would store all of its molecules. The vacuole. Oh my. I believe we're being fired at. Little scamp. Alright. We send them to the vacuole, where all these nutrients are stored. Once they collect the correct number of molecules from the vacuole, we can then send them out into the broken mitochondria. Great, we've seen how it works. Go collect substrates. So we could go to the vacuole, and you could spend the next 15 minutes watching me chase down tumbling particles of vitamin C and such. Let's go a little off the rails and see what our robot buddy has to say about it. These mitochondria, you'll notice, are not pumping out ATP. They're a much darker color. Something has definitely gone wrong. Let's take a peek inside. Going inside this organelle. So once we're inside, you'll notice that the lights are going to be much dimmer, and a portion of the ETC is going to be broken. One of the proteins in there is not doing its job properly. That makes this mitochondria very sick. You'll see down in the corner here we have a health bar. It is at 0% efficiency. Something here is not working properly. From visual inspection, I would guess that cytochrome C reductase is not working because it is not taking the electrons. We always try to have visual cues for what is not working, but we also encourage them to do the experimentation. In this case, they cannot proceed without actually performing an experiment on reductase, hitting it with the correct substrate, and if it responds correctly, it's working. If it doesn't respond correctly, well, then that's the broken one. That's the one you need to replace. And how do you replace a protein? Well, you get a new protein. The same place a plant cell would. Ribosomes make proteins. In here, we can open up a little trading window and use our ATP. Again, that's the currency of the cell. ATP powers everything. We can spend some of the ATP we have gathered to buy new proteins. And at this point, those go into our inventory, just like all of our torpedoes and our assays and our reports. And we're able to select those and replace them in the chain. And because I've jumped ahead, a robot will yell at me if I attempt to do this. So I'm just going to back out, and I'll show you a little bit of photosynthesis. Yes, I would like to quit. So we have photosynthesis and the electron transport chain and an osmosis module, and you saw the identification module. And all of them are built around this concept of show the healthy, break something, and have them fix it. What our boss likes to call the mechanics model, an auto mechanic kind of thing. That's how you learn to repair an engine, is seeing a working engine and then trying to fix a broken one. So the learning just falls out naturally from the goals and tasks in the game. When we load up here, we should be inside the vacuole of a plant cell. We are indeed. And this is the chaos that erupts in a watery bag full of nutrients. Fortunately, I was in here before and collected all of the molecules that we will need to experiment on photosynthesis. You can see I'm carrying quite a few assays. My molecules are full of all sorts of fun stuff. So we're going to head out of the vacuole here and go see if we can find a sick chloroplast. You'll see down here below all my ID and my ETC goals, I've played through some of photosynthesis already. And we need to start repairing a chloroplast. I think it's also time to turn up the music. Much better. So we'll head out of the vacuole here, and now you'll see the photosynthesis cell once this loads. And, just like the ETC, we have emphasized the organelle that this is about. So there's not so many mitochondria in here, but there are more chloroplasts. More chloroplasts, more chloroplasts. Situated all behind here. And I think there are more chloroplasts hiding behind the nucleus as well. And down here, we see we have the single healthy chloroplast. This is where you view healthy photosynthesis taking place. And we have all of these sick ones spread throughout. So let's head over to this guy here, and see if we can figure out what's wrong with this chloroplast. Scan it and go inside. Again, just like in the ETC, you saw there was a cutaway diagram of the mitochondria with its process taking place in front of it. Here we have a cutaway diagram of thylakoids, like you might see in a textbook. But here they are alive. Well, 0% health, not so much alive. Doing their best, but something is wrong in here. In the electron transport chain, one of these proteins will be broken, and you would replace it. In photosynthesis, we have flipped that around. All of these proteins are correct, but some of the raw materials are missing, the substrates. It could be carbon dioxide is not here, it could be water is not here, maybe it's not getting enough light. You can see in this one, light beams coming in like red lasers every so often, so it's probably not light. At this point, we encourage the student, the player, to perform an assay to see what is missing. You can see if there's enough water, if there's enough CO2 in the cell. Let's measure for water here. So we take our water assay, and we fire it off, and this sends a message to the server, and he comes back, our little robot partner comes back with the measurement and says that there is a normal amount of water in here. Well, that's not the issue. Let's measure carbon dioxide. Carbon dioxide. What does our robot have to say about that? He says, a severe shortage of CO2. Photosynthesis is a little more complicated. This measurement by itself may not be enough to tell us what's actually wrong. I'll show you, we have a little in-game encyclopedia here. It's not going to replace a textbook, but everything that we have in the game is defined in here in some manner. And we have, our graphics for it. Ascorbate is, I believe, vitamin C. Yes, better known as vitamin C. So in here, we have an entry on substrates. Substrates for photosynthesis. And here is where you can check your experiments to see what measurements you need to take. We have a normal amount of H2O, so it's probably not that guy. But if we are low on CO2, it could be we're low on CO2. And that might be the only test we need here. Missing Rubisco would mean we have too much CO2. So I bet we can make this chloroplast healthier by putting some CO2 in. We'll go to the inventory. We'll bring out our molecules of CO2. And we'll see if this makes any difference to the chloroplast. I'll drop this guy in. Here comes our robot. You can see we've completed the task. We've made the chloroplast a little healthier. And now it is time to move on to the incident report. This is an in-game quiz we have put at the end of each module to test learning in a more traditional way. So at the beginning of the game, there's a pre-test with multiple choice questions, and you go through that and you have an initial score. And then at the end of each module, we have these incident reports to take a quiz again, and you can measure your students' learning gains from the beginning of the game to the end of the module. Got it. I know how to report in an incident report. Thank you. These incidents reports, again, live in your inventory, just with all your other reports, and they look something like this. Incident report. I will load that up and fire it. And again, simple multiple choice quiz, 10 or 12 questions of these things. I've seen these questions before. So the player is able to do that quiz and submit it to the server, and our server grades it immediately. It has the answer key, it knows what the answers are, so the student can get immediate feedback on their score, what they did and did not get right. And I'm moving over to another report here. This is the pretest. Once the report is graded, it looks something like this. This poor guy, I rushed through and only got a third of the pretest correctly. So we can see which questions we got correctly, green text, and which ones I might have gotten wrong. So this is the interface that they see here inside of the game. As the teacher, you have an interface on the website to look at the goal progress and all of the incident reports, all of the quizzes that your students are doing. We can jump out of that right now. So the game itself, we happen to like it. We think it's a good idea. Teachers agree with us when they see us it's a good idea, but still, there's a step getting it integrated into the classrooms. We've tried to make that step as easy as possible by creating some supplementary materials around it, such as a document we call the Prepinar. This is a PDF document. It's meant to refresh the teacher's memory on what each module is for during their prep hour before class. So they stay one step ahead of the students and are able to guide them, smooth over any problems in the classroom. This starts with the normal game menu where we identify all of the menu options and the items that we saw in the game, everything on the dashboard, what every button does, and then gets more in depth with the different modules, like this one for the Electron transport chain. So we jump over here. We have a Prepinar for the Electron transport chain module. If I zoom in so you're able to read this, you'll see just bullet points, the learning objectives, what the module will cover that day or that week, what the teacher should expect from the module, and sprinkled throughout here, actual scripts, words you can use to introduce it to your class, a brief timeline of introduction, let them play the game, give them the quiz. We have the basic overview of the Electron transport chain, and then in each one, we again have this quiz. This is the same quiz you would see in the incident report. We have the answer key for yourself here in a hard copy, and below it, we also have a print version of the quiz in case you want a hard copy to hand out in your classroom. Again, all of these scores, these quizzes all happen in the game, and the scores are collected electronically and stored on the website, but if you really want a hard copy for your gradebook, you have it here. If we jump over to the website, I can show you. Logging in quickly with my account, I can show you an example of what the teacher site looks like. So every student has an account, username and password. They're able to play the game in class. If they install the game at home and log in with username and password, they'll be able to start playing from where they left off. They can play from home on the weekends, whatever. And they will have a website login like this, where they're able to see goals and tasks that they have completed here, and the date they did it. As a teacher, your view is a little more complicated. It's broken up by classes here, and you're able to expand these and see a list of all the students in your class, what they've completed, their quiz scores, and date and time they've completed that. And again, a print button for hard copies of that if you want it. I hope you like what you see. We're going to open up to questions here at the end. I'm going to go check my email inbox and see if anybody has asked any questions. No. I believe that means I answered everybody's questions in the webinar. I love when that happens. Well, you can see here, you can buy a 1-month license for a single person is only $249, but we do provide classroom discounts. And on our website. You can also go grab a demo of the game. It's shorter. It doesn't go into the ETC or photosynthesis goals, but it will let you fly around in the cells, see if it works on your computer, let you check it out for yourself on your own time. If there are actually no questions, I will thank you for your time. I'm Bob Cosmano again for WoWiWe Instruction Company, and we hope to see you in game.